Good morning, students. Uh, Today we continue our lecture with the same chapter, partial derivatives, and the topic is implicit differentiation and gradient. Okay, so let's start with the implicit differentiation. So, any function of the type f of xy is equal to c is called an implicit function where y is a function of x and c is constant. Okay, so in this case we can say that if f of xy is equal to c, where y is a function of x and c is constant, then there is one formula, that is dy by dx is equal to minus f of x upon f of y, or we can say minus del f by del x upon del f by del y. Okay. So if we have given implicit function and we want to find the dy by dx, then this is the formula. Uh, it is from the total derivative. As our given function is f, it depends on two variables, that is x and y. X is depends on itself, that is x, and y is also depends on x. Okay, so at that time, here at that time, if we apply the total derivative, then we get this formula. Okay, so let's check the proof. This proof will be asked to you in the GTU exam or internal exam for 3 marks. It is very small and easy. So let's start the proof. If f of xy is a function of x and y, where y is a function of x, then total differentiation, which we learned in our previous lecture, then total differentiation coefficient of f with respect to x is df. See, if we want to find the total derivative of f with respect to x, then this is df by dx is equal to, as we have to go f to x, but there are two ways, one from x and the other from y, and f is depends on two variables, so we are writing here partial derivative, that is del f by del x into x is depends on itself only, that is dx by dx, plus f is depends on y, so del f by del y into dy by dx. Students, any doubt in this formula? In this step? This step I am writing from this graph. Have you any doubt? Okay. So, okay, this is, if I say this is equation 1. And as our given function f of xy is equal to c. Okay, see our given function f of xy is equal to c. So if I take the derivative of f with respect to x, and this is the constant term, it means my dc by dx is 0. So if I substitute this value in this equation 1, if I substitute the value of df by dx is equal to 0, okay. So substitute in equation 1, okay. So I get del f by del x into dx by dx plus del f by del y into dy by dx is equal to what? Here del f by del x and this value is 0, so equal to 0. And as you all know students, this dx by dx is equal to what? Is equal to 1. So I keep it as del f by del x plus del f by del y into dy by dx. And if I keep this dy by dx as a subject, then dy by dx, if I keep this del f by del x on the right hand side, that is negative, so minus del f by del x. And this del f by del y is multiplied form. And if I put in the other side, it is in the division form, that is del f by del y. So this is the formula of dy by dx is equal to minus del f by del x upon del f by del y. See this, okay, which we want to prove. So this is the small proof of this formula. Okay, have you any doubt? Have you any doubt, students? Okay. So let's start the example of implicit function. Okay. That is, first question is, if y log cos x is equal to x log sin y, find dy by dx. Okay, here our given question is y log cos x is equal to x log sin y. So let's start the solution. Here what is our given function f? First we want to find our f of xy, and that is y log cos x. If I keep the right hand side on the left, then it will be minus, right? So minus x log sin y. So this is our given function. Now we want to find dy by dx, and you all know the formula of dy by dx as this. It is given function is implicit function. Okay, so here minus del f by del y upon del f by del x, right? Now the derivative of f with respect to, see, this is x and this is y. So derivative of f with respect to x. Okay. So what is the del f by del x? Anyone? Please raise your hand. I want the answer of del f by del x. What about the other students? Yes, Rishi.
Y into 1 upon cos x.
Y into 1. See, this is log cos x, so 1 upon cos x, good.
Into minus sin x.
Into, you are applying here chain rule, right? So minus sin x, okay.
Minus log
Minus log,
sin y
okay,
into 1.
into 1. Okay, so no need to write here 1 upon the value of del f by del y is
Log cos x
yes. Sorry,
minus
just a minute. Log cos x minus,
x upon sin y
yes.
into cos y.
Okay, thank you, Rishit. Students, this is if I get minus common from the numerator, right? Then minus minus plus. So here I have y sin x upon cos x, that is tan x, minus, see this is minus minus, minus I get common, so this one is plus log sin y upon log cos x minus x cos y upon sin y is cot y, right? So any doubt? Any doubt? See, we want to find dy by dx, and this is the dy by dx, right? If you have any doubt, let me know in the chat box. Okay. So let's move with one more example, that is if x cube plus y cube is equal to 3axy, find dy by dx. Okay, so here our given function f of xy is equal to, okay, raise your hand, what is our f of xy? I want the answer from all of you. Okay, so take participate. Uh, I all students. I note down that the only some students are active and the other one are not active. Uh, Kevin, minor. See, your answer is wrong, Kevin. Yes, Hitarth, you are right. Yes, Divya. Yes, Divya. What is f of
X cube plus y cube minus 3xy.
okay, minus 3axy. Kevin, as the if we keep this term in the left hand side, okay, they all are in the multiplied form. Okay, so there is one term only, and if we keep this term on left hand side, so it will be negative. So minus 3axy. Okay, thank you, Divya. Now the formula of dy by dx, that is minus del f by del x upon del f by del y. So, anyone? Yes, Tuti?
Yes, ma'am.
Huh. What is the
The answer to this question is um 3x square
yes?
minus 3ay
Okay.
upon
Hmm.
3y square
Hmm.
minus 3ax.
Okay. Thank you. Okay. So, this is okay. Okay. Many students had given answer in the chat box also. Very good, thank you. So if I keep 3 common from the numerator and denominator, then the remaining term is x square minus ay upon y square minus ax. And if I keep minus sign also common from the numerator, then the final answer is ay minus x square upon y square minus ax. Okay. So this is the value of dy by dx. Let's move with one more example, that is if x raised to y plus y raised to x is equal to c, find dy by dx. Find dy by dx. So now tell me, what is the derivative? Here, first, our given question is x raised to y plus y raised to x equal to c. It means our given function f of xy is x raised to y plus y raised to x minus c, right? And the formula of dy by dx is minus del f by del x upon del f by del y. Now I want the answer of del f by del x. I want the answer of del f by del x. Raise your hand. Okay, I am going to ask you randomly. Jay Kumar, Kunpara, roll number 69. Jay. Jay, give me the answer of del f by del x. I am going to unmute you. Give me the answer of del f by del x. Yes, Jay. Jay, are you there? Roll number 69. Okay. Roll number 40. Roll number 40.
Yes, ma'am.
Huh.
Y into x raised to y minus 1.
Okay. Y into x raised to y minus 1. Then
Yes. C is constant.
c is constant. See, this is the value of the first term derivative, y x raised to y minus 1. And in this case, here y is constant, so plus y raised to x log y. Okay? Y raised to x log y. Understand, Jay? Now the derivative of f with respect to y. Derivative of f with respect to y. Roll number 21, Dev Shah. Dev, give me the answer of derivative of f with respect to y.
Ma'am, 1 second. Na?
Dev, give me answer fast. See, students, here the derivative of this f with respect to y, that is here x raised to y, here x is constant, so x raised to y log x plus x y raised to x minus 1, right? So this is the answer of the dy by dx, answer of the derivative of the implicit function. All students, please, here you have to present with pen and paper in mathematics lecture. Okay. I will ask randomly from any one of you. And you have to ready with the answer every time. Okay. So let's take one more example. That is, if u equal to x log, if u equal to x log xy, where x cube plus y cube plus 3xy is equal to 1, find find du by dx. Find du by dx. Okay. So students, in this case, see, this is little bit different kind of example. This is example of implicit function, but the question is little bit different. Here our given u. What is our u? Our u is x log xy, right? So we keep this x log xy as x log x plus log y. This is the logarithm rule. We represent log xy as log x plus log y, right? Now, as we want to find the du by dx and from the total derivative rule, as you all know, here du by dx is what? Del u by del x into dx by dx plus del u by del y into Devanshi, please hide your camera, into dy by dx. So students, see carefully here. This dx by dx is what? 1. Okay. So no need to find it. We want to find the del u by del x. Okay. So which we find from this equation. We all want to find del u by del y. That is also we will find from this equation. But for dy by dx, we are applying this formula, this equation, and this is the implicit equation, as it is x cube plus y cube plus 3xy is equal to 1, and this is the implicit function. So we are applying dy by dx. For dy by dx, we are applying here minus f of x upon f of y formula, right? So let's start this, that is right. So let's start the solution ahead. That is, here first we want del u by del x, which we will find from this equation, and del u by del x is, we are applying multiplication rule. So derivative of x with respect to x is 1. At that time, log x plus log y, keep it same, plus x remains same, and the derivative of log x, that is what? Derivative of log x is 1 upon x. Okay, so both will be cancelled out, and the final answer of del u by del x, that is 1 plus log x plus log y, right? Similarly, the partial derivative of u with respect to y, that is x, the derivative of log x is 0, and the derivative of log y is 1 by y. So our final answer of del u by del y is x by y. Now this is our, see, we have one term del u by del x here, del u by del y here. Now we want to find the dy by dx, and for that we are applying this equation, that is x cube plus y cube plus 3xy. F of x y is x cube plus y cube plus 3xy, and if I keep 1 left hand side, that is minus 1. So this is my implicit function, right? Now the, as you know, the dy by dx is minus del f by del x upon del f by del y. So minus derivative of this function with respect to x is 3x square plus 3y upon, with respect to y is 3y square plus 3x. If I keep 3 common from the numerator and denominator, then I have x square plus y upon y square plus x. Okay. Now, as we want to find du by dx, and I already told you du by dx is, as per the total derivative rule, du by dx is del u by del x into dx by dx, right? Plus del u by del y into dy by dx. As you all know, the value of this dx by dx is 1, and the other 3 term we have already find, that is del u by del x. This is equation 1, del u by del y. This is equation 2, and the third one, that is dy by dx, that is equation 3. So from all 1, 2, 3, if we substitute all the value here, the del u by del x is 1 plus log x plus log y, and the value of del u by del y, that is x upon y, and the value of dy by dx, that is minus x square plus y upon y square plus x. Okay, so our final answer is 1 plus log x plus log y minus x upon y. This is x square plus y upon y square plus x. Okay, any doubts, students? Yes, Dhruv, very good. Very good. Krupali, Dhruv, many students have did this example. I am happy for all of you who have tried to solve. Thank you. Okay, so if you have any doubt, let me know in the chat box. Otherwise, we'll move with the next topic, that is gradient. Ma'am, can you explain dx1 again? I couldn't hear due to net issue. Devanshi. Okay, okay, Devanshi. Devanshi, in this example, see, our given value is this one is u, this equation, and we want to find the du by dx. Okay, so the formula of du by dx is what? This one, du by dx. So del u by del x into dx by dx plus del u by del y into dy by dx, because here u is depends on x and y, and x is depends on x and y is also depends on x, right? So as per the total derivative rule, this is the formula. But as you know, dx upon dx is 1. So we want to find del u by del x, del u by del y and dy by dx. So for del u by del x, see, this is our u. Okay, we are applying here logarithm rule. First we find del u by del x. Then we have find del u by del y. And from this equation, we find dy by dx, and all these three value we have substitute in this formula. Okay, Devanshi, got it? Devanshi, got it? Okay. Still, if any students have any doubt regarding any topic, let me know from WhatsApp also. Okay. What happened? Dhruv, you have raised your hand. Any doubt, Dhruv? Okay. So, students, this is okay. Okay. This was topic. This topic was implicit function. Okay. Now we'll move for the other topic, that is gradient. So let's start gradient. It is again very easy topic. So the gradient of a function f of xy is written as grade f and is defined grade f. This is the notation of the gradient. This one is I del f by del x plus j del f by del y and k del f by del z. Okay, so this is the formula for the find out the gradient. So, and the whole one is the definition. So let's start the example of the gradient. That is, find del f, this is the notation of gradient, del f at 1 minus 2 1 if f is equal to 3x square y minus y cube z square. Okay, so this is our given function. Let's start the solution. Here our given function f is 3x square y minus y cube z square. We want to find the gradient of this f, right? And the formula of the gradient of f, that is I del f by del x, j del f by del y, and k, unit vector k, here del f by del z, right? Now the derivative of f with respect to x, what is that? That is 6xy. Now the derivative of f with respect to y, so in both terms there is y, so this is 3x square minus 3y square z square. And for the derivative of f with respect to z, minus 2y cube z. Okay. Now we want to find the gradient at the particular point, that is at x equal to 1, y equal to minus 2, and z is equal to 1. So gradient of f at the point 1, minus 2 and 1, that is, we have to substitute 1 in the place of x, 2 minus 2 in the place of y, and z in the place of 1 in the place of z. So here minus 2 into 1. Okay, so if I substitute 1 in the place of x and minus 2 in the place of y, so minus 2 into 1 and into 6. So that is minus 12i plus here, if I substitute 1 here, that is 3. If I substitute minus 2 here, minus 2 square is 4. This one is 3 and this one is 1. So minus 12 minus 3. What is that? Minus 12 minus 3. This is minus 9, right? So I have to write here minus sign. This is minus 9j plus, and if I put here 1, okay, good. If I put here y, that is minus 2, so minus 2 cube, that is minus 8, and into 1, so minus 8 and minus 2, that is 16, right? So 16k. So final answer is minus 12i minus 9j plus 16k. Okay. So any doubts, students? Yes, very good. Very good, very good. So if you have any doubt, let me know in the chat box. Okay. Answers are coming that no one have doubt. Okay. So let's move with one more example of the gradient, that is evaluate gradient of e raised to r square. Okay, see, keep in mind, this is e raised to r square, gradient of e raised to r square, where r square is x square plus y square plus z square. Okay, see, now what is the formula of gradient of e raised to r square? As per the gradient of, if I keep here gradient of e raised to r square, then I del e raised to r square upon del x, right? Similarly, j e raised to del of e raised to r square upon del y, and plus k e raised to r square upon del z. Okay, so this formula we are applied to here, but as this r is depends on here, r square is what? Here r square is x square plus y square plus z square. So it depends on x, y and z. So we have to apply here chain rule. So I am starting from this derivative, that is r square is equal to x square plus y square plus z square. So differentiating partially with respect to x, y and z. So we get here 2r. First we are doing the differentiation with respect to x, that is 2r del r by del x is equal to 2x, implies del r by del x is equal to x by r. Similarly, 2r del r by del y, this is 2y. So here del r by del y is equal to y by r. And here 2r del r by del z, that is 2z, implies del r by del z is equal to z by r. Students, now we are doing the topic that is gradient. Okay, so it is different from the implicit function. So please don't combine both topic. Okay, now we want to find the gradient of e raised to r square, that is I del e raised to r square upon del x, j del e raised to r square upon del y, and k del e raised to r square upon del z. Okay, now I remains same. Here, if apply the derivative of e raised to r square upon del x, then first we have to do the derivative of e raised to r square upon del r into del r by del x. Similarly, for the derivative of this exponential function e raised to r square upon del r into del r by del y plus k derivative of e raised to r square with respect to r into del r by del z. Okay, now let me know what is the derivative of e raised to r square with respect to r. I want just yes, yes Mahir, very good. Just tell me what is the value of the derivative of partial derivative of e raised to r square with respect to r. 2r e raised to r square. Perfect. Very good. Devanshi, Harshil, yes. Yes, many students, other students are also giving the answer. Students, as this is the exponential term, this we have to keep e raised to r square as it is, and as per the chain rule, here 2r. Okay, and as you know, we have the value of del r by del x. We already find that is x upon r, right? So here x upon r. Similarly, for the next term, this is e raised to r square into 2r, and the del r by del y, that is y upon r. For the third term, e raised to r square, keep it same. By chain rule, it is 2r, and the value of del r by del z, that is z upon r. So if we keep this, see, this rr will be cancelled out, right? This rr will be cancelled out by all three terms. So if we keep this 2e raised to r square common, and then remaining term is xi plus yj plus zk. Okay, so this is the answer of the given question. So have you any doubts, students? Have you any doubts, students? If you have any doubt, then let me know in the chat box. Students, one announcement for all of you. Please do assignment by very neat handwriting, okay? Neat and clean handwriting. If you have any query regarding the assignment, you can ask me